My name is Elena, and I also work at Exactpro, and I'm part of the research and the business development teams at the company. So let me share my screen. All right. Can you see it okay?
Yes, we can.
Okay, perfectly. So today we're talking about using machine learning to test web applications. And as Lana and Arseniy have already mentioned, Exactpro specializes in software testing for complex financial market infrastructures. Though in some of our projects, we do look at user interfaces and we create tools and methods to test them. This is not the main direction of our work, and our focus is mostly on complex distributed systems. The main work is performed at the back end. So as Arseniy just mentioned, trading platforms work much faster than web applications, and during a single blink of an eye, an exchange system manages to process 3 to 5K messages in a single flow. And unlike web systems, they are mostly connected to a multitude of machines rather than to humans. Nevertheless, software testing in the area of web applications is interesting too, and the QA specialists are engaged in different types of testing around web systems, like manual, automated, high-load testing. And relatively recently, artificial intelligence methods started to influence this domain, and this is what we're going to talk about today, but a little bit later. First, I'd like to share some very useful links. I hope we will find an opportunity to share this presentation later with you. Because I'm afraid I didn't have enough time to walk through all of those sources right now, but I hope that you will be able to keep them and refer to them later. So what we are going to move on to now is the very basic structure of a web application. So let's look at it. This is a very basic version of a static web server. So here we can see the client, an application in a browser, which sends an HTTP request to the server, and the server responds by sending static content back, like HTML, CSS, images, etc. When we need a more complex content, we introduce the application servers, which are all about delivering dynamic content. So now we have web servers transferring requests and application servers concentrated on their processing. So the next step is when we make it work in a way that not every change sends a request to the server. And we add the JavaScript here, which allows us to perform calculations and checks right in the browser without querying the server. Again, as a next step, we might want to create more dynamic pages, which will use the data which is located on the server, but without reloading the whole page. For these, there are certain mechanisms created. One of those is AJAX. This allows us to send requests to the web server in the background, and still we can receive JSON and XML files from it, process them, and change the document structure accordingly. So it still involves asynchrony with requests and responses. And at the very last step, at the last level, we can use yet another technology in addition to HTTP. We can use WebSocket on top of it to create even more dynamic web interfaces. And it seems like our scheme is pretty much ready, but it still lacks one more important component of any web application. The main element and the very reason why the whole system exists is the human being. Working with any system, so we need to think about the people who are going to use those systems to make them good. So one of the main aspects in web application testing is the understanding of the fact that people use different browsers and different devices. The interface of a modern web application often needs to be adjusted to a particular browser. We just cannot test it only in one configuration. And another inherent characteristic of web applications, the one without which they practically cannot exist, they are always multi-user applications with multitasking, with high loads and parallel access. So if you want to test such an application in some meaningful way, so we should always create some load. Just several minutes ago, Arseny was talking about testing, and he explained the whole concept of software testing. I'm not going to repeat the definition itself, but I just wanted to outline two things here. So when we talk about testing, a very important concept is the one of quality, which in its turn implies that the user needs are satisfied. And the second one is that the testing itself is a process and a set of techniques which help to assess whether the software is fit for purpose, and then again some requirements are satisfied. So as you can see, here is always a human being which is involved in a process. So this is a key element. Moreover, when we are talking about finding defects, so we must remember that machines do not make mistakes, only people do. When a human being makes a mistake, a defect appears in the software system, and this defect is not necessarily seen. It can be something hidden, but it can manifest itself during the failure. So the failure is something that we can observe and which is caused by the defect. The thing is that what is visible to a human being should be evaluated by a human being. There are, of course, some parts of the systems which are used just by programs, by machines. It is okay to do the testing of such components with machines as well. Of course, machines cannot have requirements, but expectations and the needs can be programmed into them. So the following diagram represents levels of testing. Level A is on the right, and this is the easiest level. It's about the verification of the source data, which is stored in files or in the database. For this, we can use SQL queries or the command line. Then there can be various interactions between components in the application servers. By replacing one or several of them with testing tools, we can do component testing inside the application servers. Then we can go a step further and test the entire application by emulating the queries that arrive from the web server. And this is the level where all the QA work usually concentrates. So this is the most common case, and this is level C. The next level, level D, is where we can emulate requests going into web applications through HTTP or WebSocket. And another good thing about this level is that it enables us to geographically distribute the load. So the task scope includes not just application servers, but the whole thing, including the web servers as well. So the next level, level E, deals with emulation of the browser or the connection to the browser, so that we replace that part of interaction with it. The majority of the tools for functional testing of web applications perform at this very level. And surprisingly, most machine learning approaches for testing web applications also cover level E. And the last level, level F, it includes everything, including our main element, our key element, the human being. And this is where we have to think about automation. So automation is one of the directions of the scientific and technical progress. It relates to replacing the human being and reducing human effort. It might be necessary, so if you go back to this picture, it can be necessary to replace the human being on the levels E and F, whereas on levels A to D, we can actually test using machines, but at levels E and F, we have to replace human interaction with the browser. So with regards to automation, it's important to remember those two rules which were offered by Bill Gates. So the first rule of any technology is that automation applied to an efficient operation will magnify the efficiency. And the second rule is that automation applied to an inefficient operation will magnify that inefficiency. So if you're sure that your testing is effective, so go ahead and automate it. But if you choose to organize testing in some ineffective way, you are mostly likely to make it even worse. So how challenging is it to emulate a human being? So let's take a look at this question from the point of view of the web application. So if we try to imagine the simplified model of a human being as seen from the point of view of web application, human being is pretty simple and it consists of two components. One of the components is the ability to perceive information, so an eye in our case, and another one is ability to push something, so it's a hand or a finger. So, and the majority of test tools are based on this model, so they utilize those two components. But this very simple model still includes another very important component. This is the ability to comprehend, to understand the data that comes through our sensors, so the eyes, and the ability to make decisions to push something with our controllers, so hands or fingers. And the success of our test automation will depend on how well and on which level we can emulate a human being. First, let's take a look at the construct, which explains how to organize interactions between components in the model. It's called document object model, and it is based on everything that is received by the browser. And in fact, this is a model of the page. So we can go ahead and open any website, and when we do that, we can see a picture consisting of several elements. When we right-click the mouse, we can see the source code of the application, and based on this source code, the browser builds a model of the document, and based on the data that it receives from the server. This model allows the scripts to interact with different elements of the page. And here, for example, is an element. So we can see here a company, university, and here's the corresponding fragment of the code, which in its turn corresponds to a certain piece of the document object model. So the structure of the document object model is the following. So we can see it's a hierarchical structure. We can see here root element with head and body elements nested under it, and followed by all the other elements making up the entire web page. Document object model determines HTML document elements and objects. It includes their properties, attributes as well, the methods in which we can access them, and some events connected to them. So if we look at the picture that we talked about before, we can see that DOM model is also here. And here's an example. So let's imagine this is a structure of a page, and we can have the markers assigned to each and every element on this page, and we can see that it can be thought in terms of hierarchical structure. So we can see here's a sidewalk, and here we can see a road. On the road, there are cars, and there is a crosswalk, and there is a person, a pedestrian, who's interacting with the crosswalk. So we can see that a simple hierarchy can be built here. Now there are, of course, software testing tools which can interact with the elements of the model, and one of those tools is Selenium WebDriver. This tool works at the test adaptation layer. This is what connects everything else with the system under test. So Selenium WebDriver transfers commands to the browser, and they take the control over the browser. So the goal of the tool is to make certain actions with certain elements on the page, but first the tool has to find these elements, and there are several methods to do that. There are methods based on HTML, XPath, and CSS. Each of those have, of course, their advantages and disadvantages. So basically what Selenium does, it emulates the interaction with the component of our model of a human, so their hand or a finger. This is not very hard actually to implement, and there is no machine learning under the hood. But the main challenge is that when something changes, these methods can become unusable, and the test automatically breaks. So this is something that the machine learning approach is trying to solve, something that it can help with, how to make automated tests around page elements more stable. And here we are moving to the artificial intelligence part of the presentation and how it can be applied to the web application testing. So here I'm sharing a very useful link. You can make yourself familiar with the AI concept and how machine learning corresponds with AI and how it's different in AI. So we recommend this presentation here. And of course, it's a well-known fact that actually many machine learning methods that we know today were actually created long before. But the reason why the machine learning techniques and approaches are now so efficient is that something changed over the years. And here on this slide, we can see two main factors which contributed to that. So what actually changed right now is the ability to use for artificial intelligence really big data volumes and really big significant computing power. Then to utilize the machine learning approaches for software testing of web applications, we need to solve this problem, how to obtain this big data. So there are several ways to do this. Of course, the easiest one is from a database. It can also be obtained from the web server or access logs. Sometimes they're not always accessible. It can be obtained from the user data. Quite an interesting way to do it is by randomly clicking through the web applications. And the last way to obtain the big data for our testing is to use other applications. So why? Because we can find similar elements in them, and we can train our model on this big data. So if we look at one of the sources that are recommended at the very beginning of this presentation, we can see that there is a very good resource called A4Q AI and Software Testing Certification Exam. And here's an excerpt from the syllabus from this corresponding to this exam. And if we look at this list, we can see that some problems are outlined here. Some problems related to the identification of the visual elements on web pages. So let's start with this idea of random clicking. Here I will refer to the video presentation made by Jeremias Rößler from the company called Retest. And the presentation itself is a must-see. It contains many good ideas on what automated testing is. And he gives really brilliant examples. One of those ideas is the infinite monkey theorem, which states that if we give a typewriter to a monkey for an unlimited period of time, eventually this monkey, just by randomly hitting the keys, will create the complete works of William Shakespeare. And what we can do in testing, we just can replace our typewriter with a computer so that our monkey will click through any web application. And thus, again, it utilizes the function of our hand or finger in our human model. So here's a piece of the code written in Java, and what this piece of code does, it creates an infinite loop, and this loop makes the mouse travel up and down, left to right, so it randomly moves across the screen. It presses mouse, so it clicks mouse everywhere, and after some delay, it inputs a couple of characters and then presses and releases the enter key. So it is easy to create a hand, but here we can, with this approach, we can stumble upon such a problem that sometimes if there are links on the web page, our application, our tool, our code can just escape from the page and go somewhere else. So it is a bit harder to create an eye. And as for the brain, meaning that we have to understand what we have achieved, it is the hardest thing to implement. So this test was created without any reference or presuppositions about the structure of the document. So the next step is to enhance this version of the code. And now it is based on the document object model. And it also runs an infinite loop, but now it doesn't just randomly clicks. It chooses such elements as links and fields, so it interacts with directly with those elements. So we can combine those code versions, and we can potentially create an infinite number of test cases here. And what machine learning can probably help us with here is with following two tasks. First one is to understand what we have just done. Does the test have a good or a bad result? So it is passed or is it failed? And the second task is to choose the set of tests that really makes sense. So instead of going through of this infinite number of tests. The task, I'm sorry. And this is a very nice example of the brain behind this process. So for example, why we talk about this as a problem. So when we talk about what is good and what is right, the problem is called the Oracle problem. And here is another brilliant example from Dr. Rößler, demonstrating this brain element. As human beings, we can clearly see that something definitely went wrong with these logon tests. So we can see that the user entered the login, it came up with a password, and the password actually coincides with the version, but automatic test would probably pass at this moment, but as a human being, we can see this message that the password already belongs to some user. And the thing is that this user is clearly specified, which is kind of not the way it is expected. So there are ways to do the visual checks, but still the interpretation of the result is a task of a completely different scale. So we can ask the machine to predict the probability of a certain thing, but it is always up to humans to make a decision based on this prediction. And this, of course, complicates automated testing and the use of machine learning in automated testing. So the discussion about the place of a human in this equation is a very hot one, and actually the question of who must be in charge is known as the automation paradox, which was articulated quite some time ago in a paper which was called Ironies of Automation, and the paper was published back in 1983. In this paper, Lisan Bainbridge, who is a psychologist from University College London, argues that the automation does not eliminate the human, and vice versa. It makes humans even more significant. And actually, the A4Q syllabus lists the testing tasks that cannot be performed using AI. And as we can see, the very first element on this list is the definition of test oracles. So getting back to Dr. Rößler's work at retest. So fine, the oracle problem is not for machines. It is very hard to decide what is correct and what is incorrect behavior, but it is quite easy to run the difference testing. That is to check the difference and to compare what we had before and what we can have after. So there is no test oracle, and instead we just compare two versions. If the new version works the same way, that's good, that's fine, we move on. And if there are differences, in this case, we transfer them to a human being who will tell us whether this result is expected or not. One of the retest products, which is open sourced, is a Chrome extension, which works the following way. It allows to compare two snapshots of the web page. And what is shown here on this slide is actually this comparison of two versions of our Exactpro website. Actually, we compared the same page, but into versions, into different languages. And funny enough, though apparently there were a lot of differences, like as planned, the tool has clearly identified the corresponding elements, though it didn't, which is important, though it didn't rely on the element structure of the web page. And back to the problem of finding our elements on a web page. So this is the main challenge with automation. So that's why we're going back to it. And this is where AI can be effectively applied. So one of the AI-empowered tools which can help here is the tool created by a company called Testing. Though the tool is commercial, it has a free version as well. And what it does, you can record a test. For example, we recorded the logon part on this very website. So we entered the login, the password, company, and the email, the company, and pressed submit. Based on that, the system has built allocator selector model. And the model was based on the reinforcement learning. There are many ways how you can actually select an element, and what system does, the model ranks those selection methods. So, for example, the very same element, like here the the company or university. So if we're looking for this element, we can identify, I'm sorry, based on different methods. So we can identify it by its placeholder. So if it says company university, probably this is the one. Or in contrast to that, we can identify it by its location. So we look at pixel 543 or and element having the width of 245 pixels. So maybe this is an element company university, but of course this is not so. And we can see that the model understands this, and placeholder element or title attribute, they are ranked much higher than those attributes based on the position. So thinking, so you can get more information about this tool on this website, and I'm moving forward. Again, want to remind you about the document object model. And I thought that how easy it would be if the web page was just visually marked, so that we do not have to struggle with this document object model and the structure and each and every element. And the idea of in the next tool, in the Apply tool solutions, uses the computer vision for that. It gives us an opportunity not to look for differences in the formal structure of the page, but it rather looks at it as a human being would look at it. Yes, what it does, it looks at differences in the formal structure, and allows to compare the visual representations of the web pages in different browsers. So again, this example is of AI application to web application testing based on comparison. And as a next step, we can go just further and enhance this very tool with a plugin, which is described on Test Automation University portal. So there is this course called AI for Element Selection, and this course describes that very plugin. So how it works, we can open the app and we actually see the visual parts of the app with our eyes, so imagine opening something on your phone. So here's the catalog, here's the search field, and here's the shopping cart, and so on. And the visual testing tool would be that smart to do it in some similar way. For that, of course, we will need machine learning. And this course of lectures describes exactly how the element classifier is created and trained. It can be taught to find similar images to match a given example. So even if our model haven't seen this element before. And this approach does not look at the element's location or other attributes. It just identifies it based on the machine learning model and based on what it looks like. So this example in the course is around the shopping cart element, and to train this model, the creators of the plugin took a big database of the graphics depicting a shopping cart. Actually, they've taken hundreds of thousands of them. And then when the shopping cart image was given to the tool and the tool identified it correctly, it was rewarded. And vice versa, when another element was given and the tool was unsure, the points were taken from it. So the goal was to make it recognize the shopping cart pictograms, as well as to understand that any other pictograms are not shopping carts. So this tool is again underpinned by the reinforcement learning approach. Finally wrapping up, so machine learning creates quite a number of approaches to web apps testing. based on different concepts. It can be document object model, it can be visual representations of elements, it can be just random clicking. And though it can successfully work with the comparison approaches, we always have to remember that Oracle problem is not the one solved by AI. This is still a task for humans. So this is basically it. And if you're interested in software testing, you can join the webinar held by the Georgian Software Testing Qualification Board on Monday. And also we have another, something's wrong with my picture. And we also have another webinar with the Tbilisi State University this upcoming Tuesday. And I hope that the link will be in my presentation. All right. So please do not miss out on this opportunity. And another good resource to learn more about software testing is to visit Exactpro website, where we publish our research and our other interesting ideas around software testing, and our YouTube channel with the overviews of our tools and the ideas which move our work forward. So thank you so much.